Hello guys, my name is Mayank Tewatia. I'm a graduate student at ASU.
Hello everyone, I'm Pranjali Pichu and I'm a graduate student at ASU and I'm doing my first semester.
Hello everyone, my name is Sampurdhana. I'm pursuing software engineering at ASU.
Hello everyone, I'm Lakshmi Tereshri Kurvi. I'm pursuing my graduate studies in software engineering. Today we are presenting a final project for SER502 course. The language that we have created using Prolog is JP. It is a coalition of two languages, Java and Python. The design flow of our language is as follows. We will have a .jp extension file, which will be given as input to a lexer. The lexer will give out a list of tokens. The parser takes in the list of tokens and produces a parse tree. The parse tree is our intermediate code. This intermediate code is given to the interpreter, which will execute it to give us the output of our program. The language definition for JP. As I have mentioned before, it's inspired by both Java and Python. One main deviation JP has from Java and Python is our assignment operator and the equal to operator. For double equal to operator, in JP, we just use a single equal to. The single equal to is also used during declaration to assign values to identifiers. Any other assignments, we use colon equal to in place of equal to. Other than this, it is similar to Java and Python in that it supports data types int, float, string, and boolean. We also support if, then, else, and ternary operators. Alongside, JP supports while, traditional for with range keyword. Space is an operator that is not accepted by JP. Every literal should be followed by a space while writing the program. This is a preview for our grammar. We have used BNF format to represent. Now Samudanath will take over to explain about the lexical analyzer of JP.
So this is the GitHub repository for our project. So I'll download this project right now. I'll just extract all the files over here. I'll use Sublime as an editor to preview all the files, whatever we have in our project. So as you can see, we have 3 directories, and the source one contains all the files required for the execution and the compilation of a program. So the user begins with so basically the user writes the program in a file with a .jp extension, and which is according to the grammar which already mentioned. To execute the file, the user can use jpc.batch scripts. JPC stands for JP compiler. As you can see, it has all the lexical commands and the command to execute the final Prolog query. So basically, it automates execution, compilation of the program, and hiding all the unnecessary commands from the user. So I'll show you some of the lexical files. So this is the .c, the header, and the lexical file. So this is the main lexical file, which is being used to tokenize all the literals in the given program. And after the lexical analysis, the final code is stored in a .jp. Let me just execute and show you once. So after the final execution of the program, a temporary file of will be formed, so which will have the final execution statement of the program. It will have the modules of the parser and the evaluator and the final prologue query which needs to be executed. So Pranjali will elaborate more on the parser and the evaluator of the program. Two important points to remember in the language here is, first of all, when the user writes a program, one needs to ensure like after the JP end statement, so like there's no extra space or extra line written after that. And secondly, the like whenever you need to compile and execute your program, so you don't need to write like any specific code.jp or test.jp file names. So as you can see in the batch file, so whatever file name you pass as an argument, it will take that file name, execute and compile in the program.
So at this stage, we'll have the input to the parser as a list of tokens, which the parser accepts it and generates a parse tree. Now, our parser uses DCG grammar rules to execute, or to parse the whole list of tokens in top-down fashion, and the resultant parse tree will be our intermediate code for our language. So the parse.pl file will have DCG rules as shown, and once the parse tree is generated, we will have an evaluator in the runtime folder. In evaluator, we have reduction rules that are also built using Prolog. So this evaluator consumes the parse tree as an input and then generates the output. I mean, it evaluates the whole parse tree, and when we execute this eval.pl, it generates the output for the program. The demonstration of the language will be presented by Mayank.
Now I will demonstrate a few program sample runs in our language JP. So this program here, in this program we have used the data type integer, and in this program we calculate the factorial of a number. We have implemented for loop to evaluate the factorial, and finally use the print statement to print the factorial of a number. So I'll just copy paste this code to our code.jp file. I'll run it using the query jpc.batch code.jp, and as we can see, the factorial of 5 is calculated to be 120. Now in the next program, we have used the data type integer and have shown the implementation of for loop, and finally we use the print statement to print the final values of the variables the variable C. Same thing, I'll copy this code and paste it to my code.jp. Then I'll run it, and oh my God. We can see now that how the value of C changes over each recursion in the for loop. In sample program 4, we calculate the nearest power of 2 for any given number n. We have implemented this using a while loop and have finally printed the outcome using a ternary operator. I'll again copy this code and paste it to my code.jp file. And we can see that for n is equal to 40, the nearest power of n would be 32, which is the correct answer. For sample program 5, we have used the data type integer. In this, we pass three variables and we check whether those three variables are sorted or not. We have implemented this using if then else conditional statement. We can see that the numbers that we passed are 1, 10, and 5, which are not sorted. And we can see in the terminal that the outcome is not sorted. For sample program, for this program, we have used the data types Boolean, string, float, and integer. We have used the data type Boolean to showcase the working of a ternary operator. We have used the data type integer to demonstrate the working of while loop, for loops, and the if then else operator. We finally print the values of all the variables using a print statement wherein we print a string along with a few expressions. So I'll copy this code and paste it to my code.jp. And as we can see, we have the expected outcome. Thank you, everyone.